All right, welcome back to part two. So a plumber charges $75 for a service charge and $40 per hour. Plumber B charges $50 per hour, but then there's no service charge. So he charges a little bit more per hour, but there's no upfront service charge. So how many hours must a plumbing job last for plumber A to cost less than plumber B? Okay, so for plumber A, he charges $75 right from the beginning. And then he's going to add on $40 for every hour that he works. Okay, and we want our end goal. Let's go to plumber B. Plumber B doesn't charge any service charge. He just charges $50 per hour. Okay, now what sign goes in the middle? In the past, it's been an equal sign, but we want plumber A to be less than plumber B. Okay, so we're going to put a less than symbol here. We want A to be smaller than B. Okay, so now we solve this just like an equation. Let's get all the h's over to one side. So we'll subtract 40h minus 40h. So we get 75 is less than 10h. We have to divide by 10. And we end up with 7.5 less than h. Okay, now a lot of people like their h on the left side, and that's totally fine. So we can just flip it around. Just make sure the open part is pointing towards the h, right? You need to make sure it just points the same direction. And so even though you have to pay $75 up front, after 7.5 hours, it's actually cheaper to go with plumber A. If the job's only going to take 6 hours, then you should just go with plumber B because it'll be cheaper. And that's a long plumbing job, so B is probably going to be the guy. All right, so now sometimes, always, never with equations, right? We had where they are the same. It's kind of similar with inequalities. You just have to kind of think about it and use your brain. So if something is always true, you're going to get something like this. So 5 is greater than 2. Well, is 5 greater than 2? Yes, it is. Negative 3 is less than 6. Again, that's true. 3 is greater than or equal to 3. Yep, it's equal to, so that works out. Never true would be something like 5 is less than 2. Well, that's not true. Or 3 is greater than 3. It's not greater than, it's equal to, right? Sometimes true is when you're going to have a variable. X is greater than 5. Well, sometimes, yep. So if x is 7, it works. But if x is negative 7, then it doesn't. Okay, so those are sometimes, always, nevers. Is the equality sometimes, always, or never true? Well, let's solve it. Okay. Most people here will distribute, and that's fine. So we can distribute. You could also divide by 3. I'm just throwing that out there. You could. Most students will choose to distribute, and that's okay. So we distribute our 3 to both things. Okay, now let's subtract our 3x's, and they cancel out. Okay, we're left with 9 greater than or equal to 6. Is that true? Yes, it is true. 9 is always greater than 6, so always. Okay, now this one, let's combine some like terms. We get negative x plus 4 is less than negative x plus 4. And right away you can see these are the same thing on both sides, but just to finish it out here, let's add x. We get 4 is less than 4. Well, is that true? No, it's not. 4 is equal to 4, not less than. And so this would be a never. Okay. Now, if it had a bar underneath of it, so let's just pretend it had a bar, then it would be always. But since it doesn't have the greater or the equal to bar, it would be never. All right, so now we have compound inequalities. This is where you're going to have two different scenarios, and you're going to have to graph them on the same number line. So we have the solution of a divided by 2 is less than 3, and negative 3a plus 5 is less than 8. So we're just going to solve these to start out with. On this one, we're going to multiply by 2 to both sides, right? Okay, and so we're left with a is less than 6. Okay, so we can graph that on the number line here. Let's start off and we'll just do, 0, 1, 2, 3, 4, 5, 6. Okay, we'll go a little bit negative here. Okay, so we start off, let's graph this one. A is less than 6. Remember, less than is just an open dot, and it's less than, so we're going to go this way. Okay, and then our next one here, we're going to add 5. Oh, hold on. I'm not going to add 5, we're going to subtract 5, right? Subtract 5, sorry about that. Negative 3a is less than 3. And then we're going to divide by negative 3. Now, if you have zoned out, this is the time to come back, because negative, or dividing by a negative. When you multiply or divide by a negative number, you have to switch your sign around. So instead of less than, it becomes greater than, because we divided by a negative. This is very, very important. 3 divided by negative 3 would be negative 1. And so a is greater than negative 1. So open dot, and I'll do a squiggly line for that one. Okay. And so our solution, graphing the solution, is actually the shared space in between. Okay. The reason being our solution is the shared space in between is because it's the word and. Okay. So what solution, basically what numbers work in both of these equations? It works in this equation and it works in this equation. So what numbers are less than 6 and greater than negative 1? Okay, so it's everything in between the numbers. Okay, our next one here, graph the solution of this or that. All right, so we're going to just solve each of these, and then we'll see where we end up here. Get out of the way so I can see what we're doing here. So first off, we're going to add 5, and so we get negative 2m is greater than or equal to, when we subtract 5, we get 16. Okay, we're dividing by negative 2. What happens when you multiply or divide by a negative number? The sign switches, right? And so we get m is less than or equal to negative 8. Okay, we got to flip the sign around, right? Okay, and then on this one we're going to add 1. Add 1. So we get 4m is greater than or equal to negative 20. We're dividing by a positive number this time, so our sign does not change. So it stays like that. And we get negative 5 as an answer. Okay. So let's kind of graph here. Just draw some lines, and we'll call, let's see, we'll call this one negative 6, because that's kind of in the middle of our two numbers, and then negative 5, negative 7, negative 8. It's kind of all we need. Okay, now they have the equal bar, right? And so they need to be closed dots. So this first one, m is less than or equal to negative 8, and so we'll go off that direction with it. And then also, remember we have the or, so we're not looking for the common numbers. It could be either one. It could be less than negative 8, or it could be more than or equal to negative 5. And so we'll put a closed dot at negative 5, head it off into greater than land. And it could be any number this way, it could be any number that way. It just can't be these numbers in the middle. Okay, this is our last one here, graph the inequality. Now we have two inequality symbols, right? Okay, and so what that means is that it's an and equation. Okay, so we have to do 3 is less than negative 5x minus 2, and negative 5x minus 2 has to be less than 7. Okay, so we got to solve each of these individually. So we add 2 to both sides, and we get 5. Then we're going to divide by a negative number. Remember to flip your sign. So we're going to end up with negative 1. Flip our sign around, and x. Okay, now for this other one, negative 5x. We add 2 to both sides, right? Oops. Okay, and so we get equals 9. Oh, I'm not equals, I'm sorry. Definitely not equals. Is less than 9. Sorry about that. And then we divide again by a negative number, right? And so we get x, we have to flip our sign around, is greater than negative 9/5, which is roughly 1.8 if we think about it. Okay, and so both of these numbers are negative, right? So let's just hang out in negative land here. We'll say this is negative 1, this is 0, negative 2, negative 3. And that's all we really need. Okay, so the first one, we're at 0, or at negative 1. It's an open dot because there's no bar underneath the inequality. And it has to be, if we flip this around, x less than negative 1. So x has to be less than negative 1. We'll just do it kind of like that. Okay, and then negative 9/5, that's negative 1.8. Okay, so probably right about here. Again, open dot. And x has to be greater than that, and so we're headed this way. And so the solution area is right here. Basically between negative 1 and negative 1.8. That's the solution area. All right, that's it for section 5, and here are your practice problems.